Let's go over the temperature sensor that it's included on the STM32F4, and brief introduction here where we have a block diagram from page 413 of the datasheet. It shows you here that the temperature sensor goes over a multiplexer and then enters the ADC on channel 16. And it's very important, it's easy to forget in your code to control bit here so you can enable the temperature sensor and allow the signal to pass to the ADC. They give you directions on how to read the temperature, so set up your ADC channel 16, pin number 1, then select a sampling time greater than the minimum sample time specified in the datasheet, and parameterize these registers, and then they give you a formula to calculate the temperature that is with the voltage that is coming out of the ADC. Those parameters that you see over here, the V25 and the average slope, they are not on that datasheet that we have been using. You need to go to a different datasheet that it's available on Canvas, and it's called Electrical Characteristics Datasheet, page 138. They give you here these parameters that are going to be plugged into this formula. Let's go over the temperature sensor example. So we have the block diagram here, and we start identifying the blocks. So we have the GPIOs over here, we have the multiplexer, we have the ADC. We can connect some timers here to the ADC, so we can have the timers sampling the ADC or creating a fixed rate to the ADC to get the data. We have the registers where we put the output information. We have the NVIC, so we can generate interrupts, and the data bus where the data is going to be available. On the previous video, we saw the ADC timer method. What we were doing was we were sampling pin 1 of channel 9, and it was under a regular channel. It was putting the data available into the registers and generating an interrupt whenever the conversion was done, and that was the way to acquire the data. And the ADC was being sampled by using timer number 2. We didn't address this ADC clock, so we never defined how fast our ADC was running, and that's the goal of the temperature sensor example. We're going to define now the ADC clock, so we're not going to change too many things, and instead of sampling channel number 9, we're going to go to the temperature sensor here. So two things: the ADC, defining the clock of your ADC, and sampling the temperature sensor. So for that, let's look at the code. The general code does not change much from your timer example from the previous video. You have a main function, you configure your ADC, you configure your timers, you show the data, you acquire the data from the ADC interrupt, and the timer is just setting up the ADC, giving a pulse for the ADC to acquire the data. The different parts are going to be defining this ADC clock. So we create a new structure called ADC common, and here we have access to the prescaler. We are going to use the ADC in independent mode. Prescaler is going to be 2, so the ADC works out of the APB2 clock, which is running at 82 megahertz. Sorry, this should be 84 megahertz. I'll fix these on the slides, and goes over the prescaler, which is dividing by 2, so I get 42 megahertz on my ADC. I disable the DMA, I don't want the DMA, and I want a sampling delay of 5 cycles. Alright, inside of your ADC config, the difference is that instead of doing things on channel 9, we're going to route the thing for channel 16. And very important, wake up the temperature sensor. Do not forget about these, because if you don't have this function, nothing will work. And the temperature sensor is here, it's connected to that channel 16. And then at last, how are you going to show the data? It's exactly the same thing that you did before. You convert your ADC value to voltage, but now I apply the temperature equation that we saw earlier, and I have the constants here defining as macros, and they just feed the temperature with your voltage over here in volts. So this is volts, this is volts, this is millivolts, and also the millivolts constant. Alright, let's go over another example, the temperature V2, temperature sensor version number 2. So what is the difference on this one? So instead of using that timer 2, we're going to take advantage of this trigger source ability that timers have, that they can do. So timers can actually generate a trigger source that can be used by different peripherals, and the advantage of doing this is that I don't need to use the interrupt routines, and I can tie those trigger sources to these peripherals, and that's what I'm going to do. Tie it here to timer 2 trigger source that is going to do the sampling of your ADC. So let's look at the code. So now that I'm using the trigger source, I no longer need this interrupt handler, but the rest is exactly the same thing. And the difference is now I need to go to my timer, comment everything related with the interrupt routine, probably even comment this one. We don't need to enable the interrupt routines, and I select the output trigger timer 2 to be trigger source. And now I go to my ADC and I comment the external trigger, I comment those ones, and the external trigger now becomes from the trigger source of timer 2 and the edge rising of the timer. And that's how you connect both of them on a temperature sensor. So the code is available on Canvas. Take time to understand what's going on. You will be able to go in debug mode and see and if you visualize the temperature C on your debugger, you will see the temperature around 25-24 degrees Celsius. Have in mind that the temperature sensor is also not calibrated, so it's not going to be exactly the temperature that you have, but it's a start. Have fun.